Okay, let's do this on the computer. Let's do problem number 10 in your book, and I have already the file, NBA file, and this problem is about the National Basketball Association that record some data about the proportion of games won, PCT. This is the proportion of game won, the proportion of field goals made by the team. This is the field goals. The proportion of three-point shots made by the team's opponent three points, and the number of turnovers committed by the team's opponent. This is the opponent turnovers. And the following data shows the value of these 29 teams in the NBA for the 2004 season. So we have Atlanta, Boston, Chicago, Cleveland, Dallas, and these are the numbers. In this case, my dependent variables is the one that I need to predict, again, regression analysis for prediction purposes, is the percentage of games that the team will win based on the field goals, the opponent 3 points, the opponent turnovers, and so on. Okay, it's exactly the same as simple regression. You go to data analysis, and go to regression. There are no specific for multiple regression. You just go to regression analysis, hit OK. In the input Y range, remember Y range is your dependent variable. In this case, your dependent variable is PCT. So PCT, you just select all these. Okay. Then your X, all your independent variables, you have to select the 3 independent variables, the whole 3 independent variables, because you want all these 3 variables to be included as independent variables: the field goals, the opponent 3 points, and the opponent's turnover. You're going to tell Excel that the first row you have the labels, and you want your regression analysis right in here, for example. That's it. Hit OK, and what you're going to find here is your R square. R square in this case is 0.56. It means that 56% of the percentage of the goal of the games won depends on these 3 variables. Okay, that's good. What else do you have here? You have the ANOVA table. The ANOVA table tells you your F and the significant level. In this case, you have 9.9 times 10 to the power of -6, and of course that is very, very significant. So you reject the null hypothesis, and you conclude that there is a strong regression. In this case, you have a strong regression in this case. What is your regression variable? Okay, your regression variable then is going to be what? Let me write it down. These are the coefficients of your regression equation. It's y is equal to -1.23 plus 4.8 x1, and x1 is FG percentage, then minus 2.58 this variable that is opponent 3%, plus 0.03 opponent turnover. So in reality, my regression equation, y, and y is PCT, or the percentage of games won, is a negative 1.23 plus 4.8. What is this? These are the goals, the field goals that the percentage of the field goals that the team make. So every time that I increase 1% of my field goals, the percentage of winning the game is going to be increased by 4.8. The same thing happening here. Every time my opponent 3 points increase, the percentage increase 1, my percentage is going to decrease by 2.58, my percentage of winning. And this is a very small number, but it has to be considered in the equation, I guess. Sometimes you need to run the regression analysis multiple times in order to get a simple model. The simpler is the better. Sometimes if you delete one of the variables, you don't really jeopardize a lot of prediction power, if you will. Your R-square is right here, 56. Probably if you eliminate this variable, you are going to have a 0.55. That is pretty good. I mean, if you deleting one of the variables, you make the model simpler and you do not lose that much prediction power. So, okay, this is the regression equation. Now, overall, the regression equation is very significant. However, over here in your coefficient table, you're going to find the p-values for each one of the variables. Are these variables really significant, different than 0 in your prediction? And it seems that all of them, because all the p-values are less than 0.05, okay, this is 0.0004, 0.001, 0.01. So it seems that all the variables, the independent variables, really are really in significant, affecting your dependent variable. Now, multicollinearity. You can run correlation analysis to check if there are multicollinearity problems. What you do is to run correlation over here, and then you select all your variables, the dependent and independent variables. Just select all of them. You tell the system that the first row has labels, and you're going to put probably right here your correlation table. Hit OK, and the correlation tells you right here PCT. PCT has a strong correlation with field goals, 0.44. In the opponents, it's okay, but it's a negative correlation, it's negative 0.43, and the opponent team is 0.29. Okay. But what we need to have in multicollinearity is how strong are the correlation among the independent variables. You have to have a strong correlation, the dependent with your independent variables, but the independent variables should not have high correlation among them. Okay, FG do not have a strong correlation with opponent 3 point because it's a 0.09. It's a negative 0.13 with the opponent turnover, so it's good. And the opponent 3 points have 0.000 with the opponent turnover, so you have very low correlation among the independent variables, and that's a condition that you should have in regression analysis. Okay, in simple linear regression, the correlation coefficient, you can get the correlation coefficient using correlation analysis, or you can have this multiple R, but be very careful that the sign of your correlation coefficient should be exactly the same sign as your slope, or the B1 number, if you will. So that's it. I don't know, probably you want to see another example, the basketball. Okay, that's something probably that is easier because I only have two independent variables. And the salary, this is the salary of the coach. This is the revenue of the university, and that is, I think, let me get what is this problem. This is problem number 24. This is the salary of the coach, this is the percentage of winning of the team, and this is the revenue in millions, and the percentage. Okay, the salary in this case is your dependent variable. Okay, so let's run regression analysis. Data, regression, where is regression? Over here, regression. Your dependent variable is going to be salary, so select all the salaries. In this case, we have 39 data points. Then the X range has to be the revenue and the percentage of winnings. Select that. Okay, here, okay. The labels are on the first row, and you want the table to be, let's do it in here. Okay, click OK. And you have the regression analysis. You have the R squared, 31.31. It means that 31% of the coach salary depends on the revenue and the percentage of winning. Okay, it's not that good, but it's not that bad. And there is a strong correlation, a strong regression, and in this case you have 0.001, so there is a strong relation. You see over here the p-value for each one of the variables, 0.000 and 0.025, that are pretty good. So it seems that the revenues and winnings do really affect the coach salary significantly. Okay, in this case, your regression equation is the salary is equal to negative 0.68, this negative 0.68, plus 0.049 revenue, plus 0.014 percentage of winning. Okay, this is your regression equation, and it tells you that every time you increase the revenue in one unit, you are going to increase the salary of the coach by $0.049 million. And every time that you increase 1% of the winning, the coach will increase what? $14,000 in the salary. Okay, so that's pretty good. That's pretty good. And this is the data for these particular data points that we already have here. What else is important? What is important is your R squared, or the prediction power, how significant it is the regression equation, how significant it is for each one of the independent variables in the regression, and you may also, include your correlation analysis, and you want to include all the three variables in the correlation analysis, the labels, and let's put it in here. Okay, and it tells you what the salary, that is your dependent variable, is highly correlated to 0.46 and 0.44 with your independent variables, and your independent variables revenue and percentage of winning are not highly correlated. This is a negative 0.15. That is a good correlation. Okay, so we do not have multicollinearity problems in here, and that's it. That's it. That's the only thing that you need to know for multiple regression.